Welcome to the Career Development Symposium. It's really a symposium put up every year by the Career Development Committee of the Membership Committee, which is part of the structure of ASM. ASM is very interested in highlighting different careers and opportunities, and in particular to show the diversity of things that can be done. So every year we sort of change the menu around. This year you're going to hear from three different areas where there is a need for scientifically trained individuals, including individuals trained in microbiology. So the way we're going to do things is each talk is about 30 minutes, but you notice that we have the time scheduled till 5 o'clock. So what we're going to do is we're going to run through the three talks, and then I'm going to give the opportunity, we're going to break up the room, and the three speakers are going to go to one corner, and I'm actually going to sit in the other corner and do nothing, and just watch. And then you're sort of free and interact, because I think that, you know, you'll have the opportunity to talk one-on-one about things that may come up and things that you may think about. But the general mission of this thing is informational, and hopefully by the time you leave here, you will know more about opportunities in other areas. So the first talk will be given to Meryl Melnikoff, who is from the Western Institute, and she's going to tell us about a career in technology transfer.
Thank you, Arturo. Good afternoon. Excuse me. I hope that part wasn't videotaped. Okay. I'm good. Okay, thanks. Okay. All right, good afternoon, and I want to thank all of you who've come down to this session this afternoon. And I do remember when I got my degree that I was not aware of any other options, and I know that's something that's hard to learn about, and I think the ASM really should be commended for offering this type of training to all of you. So I'm here to talk about career and technology transfer, and my job at the Wistar Institute, which is a medical research institute in Philadelphia. We're about 3 miles west of here on the University of Pennsylvania campus. So my job is to head the Office of Business Development, which manages technology transfer for Wistar. So what is it we do? First I have to figure out, okay, there we go. And that's the wrong slide. So let's try, okay. There we go. All right. So it's nice to talk about a career in technology transfer, but I guess the first question is, what is it? What do we do? And then if it's something that you might be interested in, how do I find out about learning in this field? And I apologize. I know I'm hidden behind this screen. I'm not sure how to just hide. So. All right, so what is technology transfer? I thought the best way to start would really be to describe what my office does. And we promote commercialization of inventions discovered at our institute for society's use and benefit. So we really, we're very proud of the fact that without our department, many of the great inventions that have helped improve public health over the years would not have been commercialized. And this morning I had the opportunity to attend the Maurice Hilleman lecture, and Dr. Stanley Plotkin won the Maurice Hilleman Award, and Stan has developed vaccines that have literally saved millions of lives: measles, mumps, rubella, and a rotavirus vaccine. And it was actually through the efforts of my office and my predecessors that these vaccines actually got transferred from the laboratory research to Merck, who then commercialized it. So that is actually a premier example of what technology transfer professionals do when we are very successful. And not many of those transfers are that successful, but when they are, it really has a wonderful impact. We usually work at universities, nonprofit research institutes, such as the Wistar Institute, or in federal organizations such as NIH. And in my profession, people come from and go to industry. There's a lot of back and forth in that area. So when I think about my office and what we do, we have 4 primarily responsibilities. So the first is really to identify what technology coming out of research in the labs may have some value, whether it be a patentable invention, a material, a monoclonal antibody, something that's copyrightable, a manuscript or a book that has some value. Then we work with the scientists and the legal folks to protect these technologies using agreements or patenting, and we'll talk a little bit about patenting and patent prosecution. Then if our goal is to really license the technologies, we have to find partners, and that's a marketing function. And then finally, we actually get involved in negotiating the agreements with the partners for the commercial development of the technologies. So the first thing you have to understand about technology transfer is this function encompasses a lot of different types of knowledge and a lot of different types of operations, which is one of the things that, to me, makes it a lot of fun and very exciting. The other thing that's very important about this field is it really incorporates multiple disciplines. And when you're doing technology transfer, you're really working at the interface of science, business, and law. And so that means you need to understand the language of science, which those of you, because you're here, you know the language of science. But you need to understand a language of business. What's IRR? What is MTA, CDA? These are all the lingos of business, just as like, MDR is a language, multi-drug resistant is a language for your profession. And you also need to understand law. And so, as I said, what makes this exciting is really to work with all of these disciplines and with people in these areas. So the technology transfer as a profession, as an industry, did not even exist before 1980. And the reason is that most academic research, including the research at my institute, Wistar, is funded by the federal government through grants. Or it can be funded by grants from the Army, it can be funded by grants from NIH, or by foundations as well. And before the Bayh-Dole Act in 1980, if you had a government grant and you found something that had commercial possibility as a result of your research at a nonprofit institution, the government owned that invention. And therefore, if you discovered, for example, a new vaccine, as an example, the rubella vaccine that all of you have gotten, and your children get if you're old enough, was discovered at Wistar with federal funding. And we went to patent it, and the patent actually belonged to the U.S. government at the time, because this was before the Bayh-Dole Act. And as a result, for us to be able to license that patent to a company who could then make the vaccine, we had to go and get permission from the Secretary of Health and Human Services. Now, if you think of all the people working in research all over the U.S., today that's impossible. But what this Bayh-Dole Act did was this act of Congress said that universities who are doing federally funded research can then own the results of their inventions and their patents. However, that these universities were really encouraged to collaborate with companies to commercialize the inventions. And back in 1980, it's not like today where people are very used to working, industry, academia. That back then you either were an academic or you went over to the dark side of industry. And so there wasn't this back and forth. And so actually it took an act of Congress, believe it or not, to encourage universities to say, under the right circumstances, collaborating with companies can be of value. Of course, it has to be under the right circumstances. Some other provisions are that the government retains a non-exclusive license to practice the patents, And the other is that the government retains march-in rights of an invention if it ever should become of use for either national security or national health. The important thing to remember about these march-in rights is that in the 29 years since the Bayh-Dole Act, the U.S. government has never exercised its march-in rights. So these days we don't worry about those too much. And the other thing that's very important about the Bayh-Dole Act is it really, over the 25, 30 years since it happened, it's really spawned a huge industry, a lot of phenomenal successes. You know, Taxol, antibiotics, you know, so many drugs really were developed based on academic research, HPV vaccines. And so really this has been a tremendous success. And as a result, other countries have now enacted laws similar to the Bayh-Dole Act to enable their universities to engage in active technology transfer and commercialization. So where are we today? I'm going to summarize from a survey that is done every year by Autumn. And Autumn is the Professional Society for Technology Transfer, called the Association of University Technology Managers. So in 2007, their most recent survey, academic institutions in the U.S. only had $49 billion in R&D expenditures. About 7% of that came from industry-sponsored research. And all of this research resulted in nearly 20,000 new invention disclosures. A faculty member going to the tech transfer, the business development office, saying, I have something that I think may have some value commercially that could be used to improve lives, save lives, get us cleaner water, cheaper clean water. So these are invention disclosures. And out of that, over 3,600 new patents have issued to academic institutions. More importantly, we look at the impact of the licensing. As a result, in just 2007, from academic research, 686 new products were introduced into the market. Drugs, research tools to help you do your research better. Also, some of these technologies were licensed to startup companies, and 555 new companies were created. And these are new companies creating new jobs. And this all came out of 5,100 new agreements. And the other thing that is going on, and I did want to talk about a little bit, is that technology transfer offices are growing. This represents staffing level at about 300 tech transfer offices in the United States. And you can see that the staffs are continuing to grow year after year after year. So there really is always a need for really good technology transfer professionals. And that line is, it's not, it's still growing even in 2009. So, what is it that you do? So, if you're in a technology transfer office. So there's really 5 things we do. We help our scientists identify new inventions. We work with them to protect and prepare the agreements that will protect and develop new inventions. These are material transfer agreements. These are legal agreements for the most part. We manage the patenting process with our faculty. We find partners to develop the new inventions and technologies, and then when we have found the partners, we negotiate the license agreements. So in terms of identifying new inventions, what do? A lot of what we do is really outreach and faculty training. Have any of you had the experience of dealing with your tech transfer office in your institution? Okay, not many, all right. So, obviously there's a need for more outreach. We review invention disclosures, so when somebody comes to us and says, I have an invention, let's file a patent, we really review that invention, and first of all we figure out, is it patentable, and is there a market for it? We review manuscripts before publication for patentable inventions, because once you've published your manuscript, you can patent any invention in it, but your ability to do so is limited. The key skill in all of this is really understanding the science. So that's the important part. You folks really already have, 1/3 of the really key background that you need to do well in technology transfer. But then you also need to know about the market, to do research to find out what are the market opportunities. And also, it really, there's a saying, it's a contact sport. It really need to be able to interact with your faculty and get their support. So having identified inventions, and in my institution and many of yours, we have inventions, then how do you protect them other than patenting? And we'll get into that in a minute. So a lot of it is we do a lot of different agreements. My office last year, we served really only 33 PIs. That's all. Wistar is just 400 people, and we did over 200 agreements last year. Material transfer agreements, that's if you have a novel strain of virus, if you have a bacteria, a novel plasmid that you want to send to a collaborator at another institution, but you want them to be able to use it in their research, but still protect it, you do a material transfer agreement. If you want to talk with a company, you may do a confidentiality agreement. If you're at a federal lab and you want to do a collaboration, you may do what's called a CRADA, which is a collaborative research and development agreement. If you're in an academic institution, you can do a research collaboration agreement. Licenses and option agreements. We do a lot of agreements. And the key part there is we work very closely with legal counsel and the contract officers. So as I'm talking a little bit about technology transfer, the legal, the business, and the science, this is where the legal part of this comes in. The next thing we do, which also involves interaction with legal counsel, is managing the patenting of new inventions. We work with patent counsel and the inventor, and working with the inventor is key to this. We determine what may or may not be patentable. If somebody has come to me, actually one of our scientists said, I have a new flu vaccine construct. Well, tremendous market for that, but I'm not 100% sure yet what they're doing isn't something that has been done or hinted at least, in someone else's publication. So we need to check that out, because if somebody else has already done it, it doesn't meet the standard for being patentable. And then we have to figure out what is the use of the invention. Would it be a diagnostic, a research tool, a therapeutic agent, a vaccine? And what's very important, since we all must manage our budgets all of the time, is not only do we work with patent counsel to get the patents filed, but we also have to manage the cost associated with that. And that often involves some very difficult decisions. So once we have an invention and a patent, what is the reason we did this? Well, the real reason we file a patent or otherwise protect the invention is to really get a licensee. So another key function of our office is really finding the partner, marketing the technology. How do we do that? Well, one very good way in today's electronic age is we put all of our technologies for licensing on the Wistar website. So if you go to www.wistar.org, there's a link to tech transfer. There's a list to all of our technologies for licensing, and there's links to myself and the folks in my office who handle those. Also, we work with identify and contact prospective licensees. I had a half hour this afternoon, and I actually walked through the exhibit hall and looked at companies who I thought might be interested in licensing some things that we have at Wistar. And I collected a few business cards, and we'll go back to my office and we'll send them some information, and hopefully something nice will come out of it. We do presentations at business-oriented meetings, the biotech meeting, partnering forums, and the autumn meeting, which again is the technology transfer meeting that is actually attended by both people from universities as well as people from companies who want to get technologies from universities. Another way of marketing is sometimes, if you have the right technology, through press releases. So 2 weeks ago, we had a patent issued on a technology that could potentially be a universal flu vaccine. And of course, with all of the news of the swine flu, I work with my communications office. We sent out a press release, and it got picked up, and we got a story. in the Philadelphia Inquirer. So, and by the way, as a result, we got a few calls from companies. So you never know, you just have to be opportunistic. But the real big secret of marketing technologies that all the technology transfer professionals know is that the best source for identifying a licensee is usually the inventor. You folks go to clinical meetings, you go to ASM, and you know who's doing what. You see the science. And if you know, when you have a technology, you know where the scientists are working on it. So very often, when we go to market, the most important ally is really going to be the inventor. I'm going to go kind of quickly through this, but we also look at corporate partners, not only for licensing, but also today, particularly in today's days, with the funding down, looking for corporate-sponsored research. And then the last thing we do is negotiating the license agreement. And in the interest of time, I won't go through all of the details, but you have to look at business issues, the pricing, the terms, academic issues, making sure that your scientists have the right to continue to do the research, and also who is the licensee, what kind of a company are you dealing with, are they going to have the resources to commercialize your technology? If you're talking about a new vaccine, that could take hundreds of millions of dollars to develop. Does the licensee really have the resources to do that? I'm going to just switch gears for 1 second. Another option that is related to technology transfer is a patent attorney or a patent agent. And really, that is a little bit different, but again, we work with patent folks all the time. And a friend of mine who is a patent attorney said, when she trains new people, you must have a passion for science. You must enjoy writing. If you understand the science, she said, we can teach you the patent law. Very often an entree into that is to join a law firm as a scientific advisor. You can either take a patent bar, which is an exam, and be a patent agent, or you can take a patent bar exam and then go to law school and become a patent attorney. What are the personality characteristics of a good patent attorney? Again, and this also is true for tech transfer. You must love science. Be able to think creatively and strategically. How do you apply basic science to commercial applications? You have to think expansively rather than deductively. When you're doing a publication, you're always very careful not to overstate the potential implications of your findings, because you're addressing this to your scientific peers, and you want them to be able to prove or support your findings. But when you're writing a patent application, you can think of all kinds of applications of your technology, and you want to claim them. So your logic is a little bit different. You must be able to write clearly and easily, be entrepreneurial, and again, just like in tech transfer, be comfortable dealing with a wide variety of people. So getting back to my little Venn diagram, technology transfer incorporates a lot of disciplines, but really science is absolutely critical. So if you decide that this is interesting to you and you want to get into tech transfer, how would you go about doing it? Well, the first place I would suggest you go is to go to Autumn, the Association of University Technology Managers. And there's the website, www.autumn.net. They are a phenomenal resource. And what is wonderful about Autumn is because it is started out as an academic organization, people share things that in business they would never share. Companies consider all their agreements to be confidential. If you're a member of Autumn, you can go onto the website and find standard agreements from every institution, every member institution. So it's really a phenomenal organization. Also, Licensing Executive Society also is a very, very good organization, as well as NIH does some training, and also your in-house technology transfer office. So Autumn, as I said, was founded in 1974. Today it represents over 350 academic institutions. However, it has almost as many members from industry as it does from academia, because these are the people in industry whose jobs it is are to find the new technology to bring in. You hear all the drug companies saying, 80% of our new drugs are going to come from external research and development partnerships. Well, how do they get from the external research and development, academic, partnerships to the drug companies? It's through the Tech Transfer Office. Also, Autumn is rapidly growing internationally as well. And they provide wonderful professional development and networking opportunities for tech transfer. So if you're a microbiologist, you wouldn't think of a career in microbiology without being a member of ASM. As some professional in technology transfer, I wouldn't think of it without being a member and involved in Autumn. We have a lot of researchers for technology transfer, licensing survey, training programs, meetings, special interest groups. Again, probably very similar to all of the resources available through ASM. The other professional society for tech transfer is Licensing Executive Society. It's a little bit different in that its membership is geared a little more towards law firms and corporate business development people. But like Autumn, we have multiple meetings, regional, local, national, international, a little more emphasis on legal and corporate licensing issues than on academic issues. And again, like Autumn, LES has excellent training programs. And then the other place to train to be a technology transfer professional can be your university technology transfer office. Like many other careers, this is one you learn by apprenticeship. So you can look for internships in your local tech transfer office, take courses at Autumn LES. NIH has training programs, and you also might try to get a job in industry and get in licensing or alliance management departments. Autumn, I'll just go briefly through this, has basic licensing courses and the tools courses. All of this is on their website. They publish technology transfer practice manual. You want a handbook? I mean, there's a lot more to tech transfer than what's in a handbook. But if you want a handbook, that's the handbook. The website has a lot of resources, including job listings. And again, at the national, local, regional meetings, you get a chance to really learn from your peers. And no matter how long you're in this industry, you can always learn more. LES also has wonderful training programs. They call them Professional Development Series. They also will do training in conjunction with the LA Bio meetings. And they have regional and international meetings and workshops. The LES workshops are on their website, which is lesi.org. Also, I want to mention that NIH actually has some wonderful training programs. And there's two ways you can get to NIH training. One is through the National Cancer Institute, which has Cancer Research Training Awards. And these are actually fellowships. And you can also get fellowships opportunities in technology transfer through the Office of Technology Transfer Training. I can tell you, I just brought on board an associate director who works with me. This was somebody who started out with a PhD in cell biology, did a little bit of volunteer work in the tech transfer office at University of Michigan, where he did his postdoc. Then went and did a 2-year fellowship at NIH. From there, went to a major pharmaceutical company, drug company, MedImmune, and now is at the Wistar Institute. And that is actually fairly typical of the type of training and career path that people take in technology transfer. I had other people who've left my office, got trained, and went to work in industry. So that's just the way it is. In terms of training resources, another more recent one, Science Magazine has this wonderful online magazine called Science Careers, and they actually have an issue on careers away from the bench that talks about tech transfer and patent licensing. And the other thing that people ask a lot in terms of a career in technology transfer is, should I get a business or a law degree? And the answer is, it depends. It doesn't hurt, but quite frankly, the most important training you're going to get is really to work with somebody who is really, knows their job and knows it well. And it's just like, you know, you want to get a good career in the lab, you find a good mentor for your postdoc. Same thing in tech transfer. If you really want to learn it, you know, try and find people and organizations who know how to do it well and work with them. So an MBA or a law degree absolutely can help. Many of my colleagues have one or the other. I happen not to have either. I you know, PhD, microimmunology, that's it. But it never hurts. So before I end, I just want to acknowledge you know, all my colleagues who helped me learn and get where I am. Colleagues at Autumn, LES, other universities, at Wistar, industry, and WISE outside counsel. So I understand we'll be, you know, breaking into groups. If you have any other questions, if you want, you can always feel free to send me an email. You can go onto our Wistar website, and there's links to tech transfer and links to us there, or you can send me an email at melnikoff@wistar.org. So thank you very much.